Assalamu alaikum. I welcome all of you to the course on basic organic chemistry. Today we will be discussing resonance, but now it is almost the last stages of the resonance, and we will be discussing about the actual structure, that how the actual structure look like. Okay, as in all previous lectures, I was telling you that those structures in which for which more than one resonance form is possible, we cannot draw a single structure or single Lewis structure for that, or in other words, the actual structure cannot be drawn. So the actual structure can only be guessed by resonance, and right now I think that majority of you may have understood the rules of resonance. Okay, so these are two resonance forms for this amide molecule. This structure, how would this be produced? These are just arrow pushings. Okay, now those two nitrogen non-bonding electrons become a bonding electrons, they form a bond, and this 1 pi bond goes and shift onto the nitrogen, or these two electrons sits on the oxygen, they sits on the oxygen. Now here the oxygen acquired a negative charge and has 3 non-bonding electron pairs, and the non-bonding electron pair on the nitrogen suddenly disappears and a positive charge appear on it. So if someone has problem in this, they should go and watch the previous videos. Okay, this structure can be shifted to that one again by when those lone pair makes a bond, and these pi electron just sits on the nitrogen, so the pi positive charge will be disappeared and the negative charge from that will be disappeared. And as a basic rule, as we discussed, that all the resonance forms should have the same net charge. In this molecule the net charge is 0 because all the atoms have 0 charge, and here nitrogen has positive and the oxygen has a negative charge, so one positive and one negative become 0, cancels each other. So how would the actual structure look like? So one thing is that it might be like, if we look those structures, it should be like this thing. Okay, so because if we consider that this type of resonance occurs, this back and forth movement, this molecule turns into that and that turns into this, so the structure should be right in the middle. But in reality this thing doesn't occur, this phenomena doesn't occur. It is just to make us understand that this structure can be converted to this and this can be converted to this by moment of electron. But in reality the structure is stationary electron cloud. They are not moving back and forth between those two structures. Okay, so these arrows pushings, or just those canonical forms or resonance forms, are there to lead us to the actual structure. Okay, in reality this doesn't occur. The structure is like this thing. Okay, suppose we give it some numbers. Suppose this molecule has 97% contribution. These are just random values. Or this has now this has 3% of contribution. Okay, or you can have this. Now what will happen in the structure which has 97% contribution? Nitrogen has a full lone pair on it, and the oxygen has no charge. Okay, no negative charge. It has just 2 lone pairs or non-bonding electron pairs on it. But in this structure which has just 3% of contribution, so 3% contribution is less. So it has, the nitrogen has positive charge, one full positive charge, and it has one negative positive charge. But luckily this structure doesn't have 100% or 50 or more percent of the contribution. So this, as you see, that the worth of this structure is less. It's just 3%, and this is 97%. So the actual molecule should look like this. Okay, but there maybe some modification in the actual molecule, because those two are just there to tell us that this molecule, how would this molecule be behave, or how would the structure of this molecule be like. Okay, those things doesn't occur in reality, that these electron move and shift to there and it is produced and they shift and this is formed. Okay, now so guessing about those contributions, we can draw a structure. Now here the nitrogen must have its lone pair present on it. Okay, and the oxygen should have its lone pair present on it, but the electron are present in but those electrons gives just 3%, or you can say offer just 3% of its electron cloud to the bond, and those pi electrons, they just contribute, or just this electron cloud, for this electron cloud just 3% move onto the oxygen. Okay, you will understand it after when I compare this with some molecules. Now this nitrogen lone pair is not as much present on this nitrogen as of this, because now it is, we can say that it is just 97% present on this nitrogen. If we guess some, if we say that those are the values or contribution for the resonance forms. So now the lone pair is not entirely present on this nitrogen. Okay, and the oxygen is not entirely neutral. It is a little bit negative. Okay, a little bit negative mean it has some surplus of the electron. Those electrons are this electron cloud, a small part of the electron cloud goes to the oxygen, and the small portion of this nitrogen electron cloud, they just come to the they form a bond, but still all the almost 97% you can say nitrogen lone pair is present on this molecule. Okay, but now what will happen? This is not amine. It will never not behave like simple amine, and this will not behave like a simple carbonyl. It will be clear to you when you look to the structure. CH3. Here, when you look at this structure, you have a carbonyl, you have an amine, you have amine or NH2. This has an NH2 and a carbonyl, but here they are in resonance with each other. They are not in resonance with each other. Okay, so now if you have suppose you have a small one molecule of acid, automatically if you just put one molecule of an acid, let's suppose HCl, or we should not write this thing, because this doesn't exist. It must have some chlorine or something present on it. Okay, so what will happen? Now there is a competition between those two lone pairs or non-bonding electron, but as you know, nitrogen is more basic than oxygen, so this nitrogen will take the hydrogen or the acidic proton. Okay, it will take, and this will not, if it is one, so it will not take the hydrogen. Okay, because nitrogen is much more basic than the oxygen. But here there is some difference, but here it is the nitrogen which has all of its lone pair is present on it, all its electron cloud, but this nitrogen has a little bit less electron cloud present on it, as you see when you compare those structures. So it has not 100% of electron cloud, and this oxygen, which seemed to have to be neutral, is not neutral. It is a little bit negative. So the electron cloud is just distributed like, suppose I should write something like, okay, suppose these are electron cloud. So most of the electrons are, I am just exaggerating things, small on this and big portion is present on oxygen. Okay, or you can say, in other words, if this lone pair of nitrogen has this size, now this lone pair of nitrogen, its size is a little bit smaller than that one, not that much, but a little bit smaller than that one. Okay, suppose it has 100% of its electron present on nitrogen, but this structure doesn't have all electrons present on nitrogen, though majority of the electron is still present on the nitrogen. But here, as you see, that the oxygen has no negative charge, but in this structure, because some of the electrons cloud is moving to this pi bond, and this pi bond shift, and a little bit electron cloud sits on the oxygen. So in reality, or the actual structure is like that it has a little bit smaller electrons than this one, and it has a little bit more electron cloud, or you can say a little bit acquire a negative charge than this one. Now, how the behavior of the molecule changes? Now will change. It will change like if you have one molecule of HCl. Now again there is a competition, but this is not that nitrogen, because the electron cloud of this poor nitrogen is shared with this thing. Okay, I should write it like this thing. Okay, it's not 100%, it is less than 100%, but this is here the electron cloud is more on the oxygen, so this oxygen is much more negative than this thing. So that this negative charge, it will attack the HCl molecule. So as this structure will reveal us what? It will reveal us one thing, or it will show us one thing, that is, if you have a pepperamide, suppose there was no resonance and you had some HCl present, definitely nitrogen is much more acidic than basic than oxygen, so it would have taken it. But in reality, this is not taking it. The oxygen will be the one which will take it. So this structure doesn't tell us this story, that what is the behavior of this molecule, because this is the Lewis structure. So that's why the phenomenon of the resonance can come into play. So this resonance, which we say that this molecule, this structure changes to this and this changes to this doesn't occur in reality. Okay, but it just tells us that how the actual molecule will be. So the actual molecule will be like poor nitrogen with a decreased basicity, and oxygen with a increased basicity. Okay, this nitrogen oxygen will be more basic than common carbonyl oxygen, and this nitrogen will be less basic than this thing. So we should not write positive and negative on this thing. It doesn't have any positive or negative thing present on it, because these structures are not real. You can just say that some of the electron cloud is of the nitrogen, which was already present on the nitrogen, is shifted to the oxygen just because of the resonance. So it is the question that how does the scientists know that why that the actual molecule is not like this. One thing was that, which I already explained to you, that if you put an HCl on this one molecule of acid to this molecule, it will not go to hydrogen, H plus will not be attacked by this lone pair, but instead attacked by this lone pair. When you compare it to the other molecule in which the resonance doesn't occur, as you saw in the previous example, the nitrogen which was not in resonance was more powerful, stronger base, and it would have taken the hydrogen. Okay, so as you see those two structures, there is another thing. Now in this structure this is a single bond and this is a double bond. Okay, and in this structure as you see the single bond, just because this is this thing doesn't occur, okay, but it just will tell us about the actual structure. But now this structure tell us what, that this is a double bond, so double bond is shorter, and this is now a single bond, then single bond is longer. This single bond is longer than this double bond, and this CN bond is now double and it is smaller than this one, but it is not a true double bond and it is not a true single bond, okay. It is not a true single and it is not a true double because its contribution is very small, okay. So another thing which we need to understand is that this will not be a single bond, true single bond, because the electron cloud will be just like this, that it will be make this CN bond shorter, okay, and this longer. Shorter than what? Shorter than this. The CN bond will be shorter than this, and the carbon oxygen bond will be longer than this. So the electrons or the lone pair and the bond pairs, they arrange themselves in such a way that it gives a little bit double bond character to this thing and a single bond character to this CO bond, okay. So this is another thing